Hi children. So in previous video we discussed worksheet 2 problems, right? So in this video we are going to discuss about that concept 3. So concept 3 what they given here. So up to now what formulas we learned. Okay, those formulas only just addition and subtraction we did, right? So here in this concept they given that multiplication. Okay, how they given means we know the formula of, for example, tan of a plus b. Okay, we know the formula for the tan of a plus b and tan of a minus b. So, we know the formula for the tan of a minus b also. While we are adding those two and subtracting those two, already we did that problems in that worksheet 2. Okay, directly they given addition and subtraction. So, here in this concept how they given means the first concept and the first theorem is tan of a plus b into tan of a minus b. So, this is the first theorem. Tan of a plus b into tan of a minus b. Okay, so tan of a plus b into tan of a minus b is equals to tan square a minus tan square b by 1 minus tan square a into tan square b. Okay, just read this, see this one carefully. So, we know the formula for that tan of a plus b. Tan of a plus b formula is tan a plus tan b by 1 minus tan a tan b. And tan of a minus b formula is tan a minus tan b by 1 plus tan a tan b. So, here they are asking the product of those two formulas. After getting that, after doing that those two multiplication, here we are getting that resultant as tan square a minus tan square b by 1 minus tan square a tan square b. So, this is the first theorem. They given that some theorem. So, this is the first theorem. So, here proof. So, see here proof. Okay. So, tan of a plus b. So, I want to take that LHS here. Okay. So, what is that LHS? Tan of a plus b into tan of a minus b. Tan of a plus b into tan of a minus b. So, directly you do that formulas here. Tan a plus tan b whole by 1 minus tan a tan b into here tan of a minus b. So, tan a minus tan b whole by 1 plus tan a tan b. 1 plus tan a tan b. So, here this product we have to do that. So, just observe that this is in the form of, if you take these two as together, okay, together only we have to take, no. Now, see here, a plus b into a minus b. Just observe that only numerators, a plus b into a minus b. And the denominators also a minus b into a plus b. Clear or not? Okay. So, this is in the form of a plus b into a minus b. So, already we discussed this one in this chapter also. So, a plus b into a minus b is equal to a square minus b square. So, by applying this identity, here we will get that answer. So, tan a plus tan b into tan a minus tan b whole by 1 minus tan a tan b into 1 plus tan a tan b. Okay. So, a plus b into a minus b by a minus b into a plus b. So, which is equals to, so tan a plus tan b into tan a minus tan b. So, a square minus b square. So, which is equals to tan square a minus tan square b. Okay. Whole by, here a minus b into a plus b, again a square means 1 square minus, here it is tan a into tan b, here also tan a into tan b. So, which is equals to 1 minus tan square a into tan square b. Okay. So, 1 square is nothing but 1 only, no. So, here we got that RHS or not. So, finally we got that RHS. We taken that LHS, so we proven here RHS. Tan square a minus tan square b by 1 minus tan square a tan square b. So, here 1 square is nothing but equals to 1 only, no. Okay, so 1 minus tan square a tan square b. So, what is the formula again here? Tan of a plus b into tan of a minus b is equals to So finally what we got here? Tan square A minus tan square B whole by 1 minus tan square A tan square B. Okay, so hence it is proved. Hence it is proved. Am I clear, children, here? Okay, so this is the first theorem. What is the first theorem once again? Tan of A plus B into tan of A minus B is equal to tan square A minus tan square B by 1 minus tan square A tan square B. Clear, children? So this is the first theorem. So let us see that second theorem. The second theorem is cos of A plus B. Cos of A plus B into cos of A minus B, which is equals to cos square A minus sin square B or cos square B minus sin square A. Okay, children, this is the second theorem. What is that? Cos of A plus B into cos of A minus B is equal to cos square A minus sin square B or cos square B minus sin square A. So this is the second theorem and the second formula. Okay, so see this one carefully. So cos of A plus B into cos of A plus B into cos of A minus B. So first I want to take that LHS. In that proof, I want to take that first. Always we have to take that LHS only, no? We have to take that LHS, we have to prove that RHS. So here, see this. So cos of A plus B into cos of A minus B. So first say this one. So cos of A plus B formula is cos of A plus B. Cos A cos B minus sin A sin B. Okay, into here this is cos of A minus B. Cos A cos B plus sin A sin B. Clear? Okay, cos of A plus B and cos of A minus B formulas we written. Now here we have to do that simplify. So again just take it as cos A cos B as A. Here also cos A cos B as A. And sin A sin B as B. Here also sin A sin B as B. Now just observe that one here. Okay. So cos A cos B minus sin A sin B into cos A cos B plus sin A sin B. Which identity here again we have to use? Always here most probably we have to use the identity as A plus B into A minus B is equal to, here this is A plus B and this is A minus B. So A minus B into A plus B, which is equals to A minus B into A plus B is equals to A square minus B square. Okay, that formula here we have to use again. So A square. So A square means A is equal to cos A cos B whole square minus here B square. B square means sin A sin B. Sin A sin B whole square. Okay, A square minus B square. Now apply that square to that ratios. So cos A cos B whole square means cos square A into cos square B minus sin square A into sin square B. So here we got this one. Okay, but in that formula here we have that cos square A minus sin square B or cos square B minus sin square A. So here children we know that three identities. Okay, in the trigonometric ratios we learned that three identities. What are those three? Cos square theta plus sin square theta is equals to 1. Cosecant square theta minus cot square theta is equal to 1. And secant square theta minus tan square theta is equal to 1. Okay, so what is the first identity? Cos square theta plus sin square theta is equal to 1. So what is that identity here? Cos square theta plus sin square theta is equals to 1. Am I clear? That is the first identity, no? Three identities. So out of three here, this is the first identity. So I want to change that cos square B here. Okay. So cos square theta I want to write. So cos square theta is equal to 1 minus sin square theta. As I know, just I am transposing that sin square theta from LHS to RHS. So here we have that 1 minus sine square theta. Clear? So here just substitute that cos square A into, at the place of cos square B, 1 minus sine square. Here B is there, no? So that's why here that is 1 minus sine square B. At the place of theta, here we have that B, no? So that's why. Minus, here I want to change that sine square theta. So sine square theta is equals to 1 minus cos square theta. Whatever it may be, like this we will get, no? So here 1 minus cos square A. Why? Because here A is there, no? So that's why A into sine square B. Am I clear? Now do that multiplication. Cos square A into 1. So which is equals to cos square A minus cos square A into sine square B. So cos square A into sine square B minus into 1. So or leave like this one. Later we will say that. So 1 into sine square B. So which is equals to sine square B minus cos square A into sine square B. Cos square A into sine square B. So after multiplication this one we got, no? Now here again do that with multiplication with a negative sign. So what we will get here? Cos square A minus cos square A minus cos square A into sine square B. Cos square A into sine square B. Okay. Sine square B. Minus into plus is equal to minus sine square B. Minus sine square B. And here it is minus into minus is equal to plus cos square A into sine square B. Okay. Plus cos square A into sine square B. Okay children. Now is there any possibility for that cancellations? Yes, see that any cancellations possible or not? Here minus cos square A sine square B and here plus cos square A sine square B gets cancelled. Okay. So finally here leftover terms cos square A minus sine square B. This is the first formula what we got. Okay. So cos of A plus B into cos of A minus B is equal to cos square A minus sine square B. So another formula also there. No, what is that another formula here? Cos square B minus sine square A. So how you got this formula? Okay. Similarly we will get this one. Just why here B and A changed means just observe that here I changed that cos square B. Cos square B I changed. So that's why here we got a formula as cos square A minus sine square B. Okay, why? Because here I changed that B and here I changed that A. So B and A gets cancelled. After here we are getting that A term and here B term. Okay, if you change that first cos square A term, if you change that one, then here we will get it as cos square B term. Okay, shall I explain you this one? Okay, for this question I will explain you that. See, so here we got it as cos square A into cos square B minus sine square A into sine square B. So just take this step, cos square A minus cos square B, cos square A minus, cos square A cos square B minus sine square A sine square B. So previous I changed that cos square B term and here A term I changed, no. Now I want to change that A term and here B term. Clear? So see that. So I want to change that B term. Sorry, here I want to change that A term and here I want to change that B term. Okay, just see here. So again formula, what is that? Cos square theta plus sine square theta is equals to 1. So from this one what we can write? Cos square theta is equal to 1 minus sine square theta. And here sine square theta is equals to 1 minus cos square theta. Okay, by using those two formulas just like the previous one only. So here cos A I want to write it as 1 minus sine square A into cos square B. Okay, and here minus sine square A. Already here A term I changed, no. So here I want to change that B term. So sine square A into 1 minus cos square B. Okay, so just simplify that. cos square b into 1 is equals to cos square b minus sin square a into cos square b. Okay, next minus into plus is equal to minus sin square a into 1 is equals to sin square a. Okay, minus into minus is equal to plus sin square a into cos square b. Okay, any cancellation terms here? Yes, again here sin square a cos square b, sin square a cos square b. Those two also having the two opposite signs. Here negative sign is there, here positive sign is there, no? So that's why. So left over cos square b minus sin square a. Yes, hence it is proved. Okay, children, just say that again. So here we got that cos square a minus sin square b. Why? Because in that previous I changed it that b term, and here after that negative sign I changed it that a term. So that's why I got this formula. So here I changed it that first a term, after that I changed it here b term. Okay, so that's why here we got this answer. Okay, so that's why here what are the formulas for that cos of a plus b into cos of a minus b? Here we have the two formulas for that. So cos of a plus b into cos of a minus b is equal to cos square a minus sin square b or cos square b minus sin square a. Okay, children, it is clear? So here in this video I explained you the two theorems. So the leftover theorems I will explain you in that next video. Okay, thank you.